Hi, welcome back. Once again, I'm welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. We are happy to announce that now Unacademy is going to providing online training for GATE and engineering service exams. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, first we check how to get Unacademy learning app into your device. Just go to Play Store, type Unacademy, and click on this install button. Then once you type Unacademy, it will show the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. See what you will get. So by joining Unacademy, what you will get. See, first of all, you have a regular daily live classes. Every day you have a live class. The intention to conduct live class and every day is always to keep the student in touch with the subject. For that reason, we are conducting every day online class. And structured courses, live tests and quizzes, and unlimited access. These are the benefits you are getting. These are the services we are getting from Unacademy. So live classes. In live class, what you are doing? In live class, you can chat with your educator. You can engage in discussions and ask your doubts and answer polls. All those things you can do while class is going on. All those things you can do while class is going on. Okay. And structured courses. Here, all our courses are structured in line with your exam syllabus. In line with your exam syllabus to help you best to prepare for it. For proper preparation, first you should know what is the exact syllabus, and that syllabus should be organized well. Okay, so you can done that by using this, and after that you can evaluate your preparation with our regular mock tests and quizzes and get detailed analysis on your performance. Get detailed analysis on your performance. And after that, unlimited access. So once you're taking a subscription, you can access to all our live and recorded courses to watch from the comfort of any of your device. Once you are taking the subscription, you can view or you can access all the live classes as well as recorded courses. Okay, all those things you can view number of times from comfort of any of your devices. There are two subscriptions, iconic subscription and plus subscription. In plus subscription, what are the things? Just before I told you, daily live classes, structured courses, live tests and quizzes, unlimited access. All these things you get by taking a plus subscription. Okay. And in iconic subscription, what are the facilities get by the plus subscriber? You get all those benefits. In addition to this, you are getting these things. You are getting a personal coach. You can track your study record, your progress, and mains question and answer practice. Here, personal coach. See, get one-on-one guidance from top exam experts as your personal coach. Okay, that means we take the exam experts and we assign that exam expert as a personal coach to you. Okay, so once you've written some exam, you attempted some question. Okay, in you attempted one question in your exam. Now that question is wrong. Now once that question is wrong, where you done mistake, he will analyze that, and based on that they will prepare a proper study plan to you, and respect to material also they will provide to you. Okay, so all these things you get from your personal coach. Okay, next, study tracker. So you can participate in study tracker plan and study booster workshops. Evaluate your progress in bi-weekly reviews with personal coach. In bi-weekly reviews with personal coach. Okay, and next, mains question and answer practice. So to strengthen your mains answer writing through regular practice with evaluation and personalized feedback. With evaluation and personalized feedback. Okay, so mains question and answer practice. For engineering service exams, there is a second paper we have mains. In that, you need to answer the question. You need to write the answer for that question, not fill in the blanks or objective questions, descriptive question. Okay, you need to practice that before going to exam. You need to practice. You need to answer more number of questions. Now, during that practice session, we evaluate your answers, what you are writing, and based on your writing, we will give a proper feedback to you by evaluating that. All those things are additional things you get compared to plus subscriber. You get these things by taking iconic subscription. Yeah. Now, see this, Unacademy combat is going on. So again, it is going on in the month of April. So already April 4th, 11th is completed. Now April 18th, 25th, two combats is there. So coming Sunday, there is a scholarship test worth of 3.5 crores plus combat scholarship test in the month of April itself. Okay, now this is for GATE and engineering service exams. So my dear students, don't miss this opportunity, and to enroll now itself, and during enroll use my code VRAO10. So the test is duration of the test is 60 minutes. It will start at 11 a.m. Duration is 60 minutes, and these are the branches: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. Now the prizes are: top 3 winners from each department get a 100% scholarship on plus subscription. Okay, and 100 winners from each branch will be given additional discounts. So to unlock the test, use my code VRAO10 to unlock your test. So from this, what you are getting from this online test, what you are getting is, it is the India's largest weekly scholarship test for GATE, and assess your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators, and take it live to compete with the best, and super fast and fun with All India live leaderboard, and identify and improve your weak areas through detailed video solutions. Okay, so don't forget to use my code VRAO10 to unlock the test. So these are the GATE 2021 rankers who benefited from GATE Combat, which is conducted by Unacademy. Okay. Now we are going to problems on transistor amplifiers. Already we solved. Before going to that, different parameters for different amplifiers we will mention here. and already we solved a few problems in this. This is the condition you need to apply approximate model. Yeah, see this question. In the amplifier shown, the transistor has HFE 60, HIE 1.5K, HRE 2 into 10 power minus 4, and HOE is 20 micromos. Calculate voltage gain, input impedance, and output impedance. First of all, you need to identify which amplifier it is. Input is applying at base input, and output is taking at emitter. So this is a CC amplifier. CC amplifier. So once it is CC amplifier, okay, we know the values of this. Voltage gain AI. Okay, so voltage gain value, we know that voltage gain AV is 1 minus HIE by RI. And one more, sir, the load RL value is here 2 kilo ohms, which is less than 4 kilo ohms. So we can go for approximate model. Therefore, approximate model. So I'm going to approximate analysis. So 1 minus HIE by RI. So we need first RI. So RI is HIE plus 1 plus H of E into RE, because there is no external load RL. That's why I'm taking RE directly. So here is RE, this is RE, R1, R2, RS, and we can write RB as R1 parallel with R2. RB as R1 parallel with R2. Now just substitute the values in this. HIE 1.5K plus 1 plus H of E 60 into RE 2K. So which is 61 into 2, 122 plus 1.5, 123.5K. That is the RI value. Now I am substituting that RI in that AV. Therefore AV can be written as 1 minus HIE is 1.5K by 1.5K by 123.5K. So now it is 1.5 divided by 123.5, 0.012 minus 1. So it is 9.9878. That is the voltage gain. Okay, that is the voltage gain. So voltage gain is over, RI also over. Next, R naught. So R naught for CC amplifier is RS dash plus HIE. R naught is RS dash plus HIE by 1 plus HFE. Already in first slide I have written all this. Okay, now we need RS dash. So RS dash is RS parallel with RB. Okay, now we need to get RB first. After that RS dash, then substitute here. So R naught we need, which is RS dash plus HIE by 1 plus HFE, and RS dash is RS parallel with RB, and RB value is R1 parallel with R2. So R1 parallel with R2 is 47k parallel with 33k. 47k parallel with 33k, which is 47 into 33 divided by 80. That is 19.4 or 19.38 kilo ohms. And RS dash is RS parallel with RB. So 19.38k parallel with RS. RS value 1k. 1k. That is 20.38. That is 0.95 kilo ohms. That is RS dash. Now substitute the values in that. Therefore R naught is RS dash 0.95 kilo ohms plus HIE 1.5k by 1 plus H of E 60 they given. H of E they given 60. Now simplify this. One 1.5 plus 0.95, so 2.45k divided by 61, 40.1 ohms. That is the output impedance. See, whatever the analysis we done on CE amplifier, CB amplifier and CC amplifier, you have to consider that is the basic analysis. In problems, you need to convert your problem into the equivalent of that analysis, that circuit, what you studied, basic circuit. Okay, and then it is very easy to you. So once you are thorough with that analysis, now every equation is going to be noted to you, and just write down the equation or formula, symmetry it, and then take the value, substitute in that. Very simple. If circuit is any bit little bit different, then we need to do the more analysis on that. That means you have to write the AC equivalent of that. After that, replacing the transistor by its H parameter, okay, or R pi model, like that. Required analysis we need to do. Next, see this. In the amplifier shown, the transistor has H of E equals to 60, HIE equals to 2K, HOE is 25 micromole. Calculate AV, RI and R naught. You observed one thing here, 40 kilo ohms resistor is there. 40 kilo ohms resistor is a feedback resistor. It is a feedback resistor between input and output, both are, it is feedback, and it is a common emitter amplifier. Okay, first I am going to converting this one into a equivalent circuit. Okay, so see this. Now whatever the 40 kilo ohm resistor here we have, I am going to be simplifying that like this. First AC equivalent I am going to take it. For AC equivalent, capacitors are short circuited. First I am going to taking that capacitors are short circuiting. After short circuiting of capacitors, your circuit is like this. And taking output here, clearly they mention this is a VI. Here is the resistor, feedback resistor. Now feedback resistor I am writing. So this is the feedback resistor. It is a 40K plus VCC. It is a 2.7K. .7K. Sir, it is 2.7K. There is a point, and after that its value is 2K. Now there is a feedback resistor. What we have to do with that feedback resistor is very simple. Just apply Miller's theorem. Apply Miller's theorem. Okay. So according to Miller's theorem, now applying Miller's theorem. See, by applying Miller's theorem, whatever the, so first Miller's theorem states that a resistor is connected between input and output. Let us take an amplifier. For that amplifier, a resistor is connected between input and output. This is input and this is output. Now it can be replaced by its equivalent at input side as well as its equivalent at output side. This is input and this is output. Same amplifier. Now its value at input is R by 1 minus voltage gain. It is R by 1 minus 1 by voltage gain. Here AV is voltage gain, output voltage by input voltage, V0 by Vi. Okay, the same thing I am applying. Here 40 kilo ohms we have. Now I am taking its equivalent at that here and its equivalent here also. It is 40K by 1 minus 1 by AV. It is 40K by 1 minus AV. So this is 2K, 2.7K they given. This is the circuit. Now in this circuit, see AV, this is CE amplifier. It is a CE amplifier. In CE amplifier, voltage gain AV is much greater than 1. Therefore, from this we can write 1 minus 1 by AV is much less than 1. Okay. 1 by AV is much less than 1. Therefore, 1 minus 1 by AV can be written as approximately 1. So we can write 40K by, therefore 40K by 1 minus 1 by AV can be written as approximately 40K. Okay. And I am keeping this 1 minus AV as usual. Later we calculate that voltage gain and substituting that AV value in that. Now I am taking the next level of equivalent circuit. Now this is the circuit at present we have. Yes. It is 2.7K. It is 40K. It is 40K by 1 minus AV. Here is 2K. It is VI. Now this is V0. It is plus VCC. This is our circuit. Now I am going to comparing this with your regular CE amplifier. So I am taking it as RC. I am taking it as RL. Taking it as RB. Taking it as RS. And you can treat it as VS. Okay, you can take it as VS. Now I am taking this is a input voltage V in. Okay, now the AV is here V0 by V in. V0 by V in. Okay, now so RL dash first I am going to calculating because first I want to know whether I have to go for either exact model or approximate analysis. I want to do. For that first I am calculating RL dash, which is a 2.7K parallel with 40K. No doubt it is less than 2.7K. It is less than 2.7K. Okay, so therefore we go for approximate. So it is less than 4 kilo ohms. So I am going to remove this 4 kilo ohms, less than 4 kilo ohms. So therefore we go for approximate analysis. So first I am calculating RL dash in that process. RL dash is 2.7K parallel with 40K, 40 kilo ohms. So simplify this. 40 into 2.7 divided by 42.7. It is 2.52 kilo ohms. Okay, now go for current gain. So what we need to calculate? Voltage gain Ri R naught. For that we need to calculate current gain. So current gain is AI is minus H of E. So they given H of E value 60, which is minus 60. Second, Ri input impedance, HIE input impedance. They given HIE value 2 kilo ohms. So next Ri dash. Okay, before going to Ri dash, I am going to calculating AV, because for calculating AV this Ri is sufficient. AV is minus H of E into RL dash by HIE. So minus 60 into RL dash 2.52K by 2K. KK gets cancelled. Minus 60 into 2.52 by 2. So that is 30 into 2.52. 75.6 minus 75.6. That is the voltage gain. Now take that and calculate this RB. Now RB is 40K by 1 minus into minus plus 75.6. So it is a 40 by divided by 76.6. 0.522. 522 kilo ohms. Okay, that is the RB value. Now, so now we go for RA dash. RI parallel with RB. RI parallel with RB. 2K parallel with 522K. So that is 2 into 0.522 divided by 2.522. That is 0.413. 413 kilo ohms. Next, RS dash. Sorry, RIS. RIS including source resistance. RS plus RI dash. Sir, here we are taking RI. This is RI dash. Here I am taking RIS. RIS is RS plus RI dash. So that is a 2K plus 0.413K. That is 2.413 kilo ohms. So next what they want? R naught. They want R naught. So R naught is infinity. R naught dash is R naught parallel with R naught parallel with RC. R naught double dash is R naught parallel with RL dash. That means R naught dash, which is RC 2.7K. After that, which is R naught double dash is R naught, it is RL parallel with R naught dash. Okay, this is a 40K parallel with R naught dash is 2.7K. Now get the value. 40 into 2.7K. See, this is nothing but your RL dash. 2.7K parallel 40K, 2.52K. So it is a 2.52K. This is your R naught dash. Simple. Just once you are familiar with the basic circuits what we discussed in previous sessions, based on that knowledge you can easily convert your circuit into that standard model, and after that you can write that respective equation and you can substitute the values in that, not more than that. It is very easy. Okay, next. So next one is next problem. See this, calculate the voltage gain AV. Simple. If H of E is 60, HIE 1.5K. Here they given clearly RL is nothing but RC, that is 2 kilo ohms, which is less than 4 kilo ohms. Directly we go for approximate model. Approximate analysis. So voltage gain AV is, see they are asking voltage gain of this circuit. So they did not mention anything, simply Vs by, so you need to calculate Vs by V0, V0 by Vs you need to calculate. So that means you need to calculate finally AVS. We know the value of AVS. AV into R I dash by R I dash plus RS. First I am writing simple voltage gain AV, which is minus H of E into RL by or RL dash by HIE. See, minus H of E is minus 60 into RL is nothing but RC 2 kilo ohms by HIE is 1.5 K. Okay, so this is in 4 times, 40 times, which is minus 80. Now, RI value of this one is HIE 1.5 K. And RI dash we need. So RI dash means RB we need. So RI dash is RB parallel with RI. So first we need RB. So RB value is R1 parallel with R2. So that means 5K parallel with, see this is R1, it is R2. 5K parallel with, this is RS, RC. 5K parallel with 15K. So how much it is? That is 3.75K. So now here 1.5K parallel with 3.75K to 1.5 divided by 4.4, 5.25, 5.25, that is 1.07K. Substitute, so minus 80 into 1.07 by 7K by RI dash 1.07K plus RS 1K. So that is divided by 2.07 is 0.51 into 80. So that is 41.4 minus 41.4 approximately. This is the voltage gain. Okay. So for this circuit they are asking voltage gain. Okay, here I differentiated AV and AVS. Okay, so this is the voltage gain without source. This is voltage gain including source. Next, see this. In the circuit shown in below figure, assume that the capacitor is almost shorted for the frequency range of interest of the input signal. So the meaning of that is at all operating conditions this capacitor is short circuited. That is the meaning of this. Okay, so capacitor is short circuited at all operating conditions. Under this condition the voltage of the amplifier will be approximately, sorry sir, voltage gain. So the letter gain is missing. Voltage gain of the amplifier will be, see, voltage gain means we know that V0 by Vi. Clearly they mention this is V0 in this is the next voltage. So we need to calculate this one by this one. In previous circuit also you observed they asked simply voltage gain. Okay, they used the letter AV. So only two voltages. This is the V0 and this is the Vs. So they want this one by this one. That is the meaning of that. They did not mention any intermediate voltage Vi like this here. So this calculation of AV V0 by Vi just for our easy simplification purpose. We are assuming a input voltage Vi here and V0 by Vi we are calculating for our easy understanding purpose, easy simplification purpose only. Once they give in the circuit what are the two voltages, output voltage and input voltage is available, that output voltage by input voltage, that is the voltage gain, that's it. Next, now we need this V0 by Vi. So okay, now let us, I am going to taking one thing. First I am taking voltage, here is Vx. This is CC amplifier, you observed or not, CC amplifier, because input is at base, output is at emitter, so collector connected to supply, so it is a CC amplifier. Okay, that to load is 0.66k. We go for approximate. So its voltage gain is V naught by, see they want see this is the voltage gain. AV is, I am taking, let AV is V naught by Vx. Let us. So V naught by Vx is, no doubt, it is 1 minus HIE by Ri. Okay, and it is approximately 1. Which is approximately 1. Now in options we have 1. Okay, there is a chance of going to that, but they want V naught by Vi. Now I am taking the AC equivalent of this circuit. Okay, AC equivalent of this circuit. See this. What is the AC equivalent of this circuit? So here we are assuming Vx, V naught, Vi. So these capacitors are short circuit. Now, once we take the AC equivalent of this, now this DC supply connected to ground. So it is connected to ground. It is also connected to ground. And once it is 66k grounded, another 66k ground is there. Now both are in parallel. So its equivalent is so collector connected to ground, and here already 166k connected to ground. This is 0.66k, and they are taking output from this. And in addition to this, this 66k is connected to ground from base. This 66k is there. For this, a 33k resistor is connected. This is our Vi. Previously we assume we taken this is our Vx. Okay, now see this, both are in parallel. This both of these 66k parallel, and its equivalent resistance is 33k. Now the circuit is like this. This is, it is Vi 33k, another 33k, another 33k, and this is the voltage Vx. From this we can write Vx equals to Vi into 33k by 33k plus 33k, that is Vi by 2. But just before we calculated, V naught by Vx is 1. Now in place of Vx I am writing Vi by 2. Therefore V naught by Vi by 2 is 1. Therefore V naught by Vi is 1 by 2, 0.5. This is the voltage gain what they want. 0.5. This is the voltage gain what they are asking. Now the option is, this is the right option. So before going to solve that, once you need to check the problem. Yeah, next. So this is a very nice problem. Calculate the output voltage V naught of t when Vi of t is x cos 10 power 60 plus y cos 10t is applied, and you can take h of e, hie, these values, h of e and hie values, these. Okay, so under these conditions, what is the value of output voltage? See this? Now the difference between this problem and the previous problem is, see, this is the Vi of t, clearly they mention this is Vs, that means this is the Vi, this is the, sorry sir, so there is one mistake in this problem, one data is missing, they need to give the capacitance value. So you can assume the capacitance is 10 microfarad, just take the capacitance is 10 microfarad, capacitance is required for this problem, and this is Vi of t. So this is the modification you need to do in this problem. Okay, now, sorry, now see one thing, this is the, now drop across RS, you can neglect, drop across this 1 kilo ohm you can neglect, it's not an issue. So you are taking it is Vi of t. Previous conditions, previous problems and this problem, the main difference is your input signal simply they given Vi of t in previous problems. But in this problem, Vi of t given in two components, x component one, other one is y component. And x is x cos 10 power 60, y cos 10t. Okay, this 10 power 60 is in terms of omega t. So this is the input data what they given. So Vi of t is x cos 10 power 60 plus y cos 10t. This is the data they given. Okay, now what is the output voltage? Clear? Okay, first calculate overall voltage gain. Overall voltage gain is minus h of e into RC by, because it is CC amplifier, by HIE. Substitute values, minus of h of e 80 into RC 3k by HIE 2k, 40 into 3 minus 120. This is the gain. Now you are expecting your output voltage is V0 of t is so not like this, sir. You can assume, you can give priority to capacitor, that's it. Okay, capacitor, and you can assume that signal is here. Now it is 120, voltage gain is 120. Now once it is 120 minus 120, you are expecting output voltage is minus 120 times Vi of t. This is we are expecting, because voltage gain is a V0 by Vi. So minus 120 Vi of t. So answer is either A, or here also negative is there. Now either option is C or D or A. It is plus, so not possible. Now the important thing here is they given different frequency components, 10 power 6 and 10. So let us, I am comparing this one with a standard signal. Our standard signal is x1 cos omega 1t plus x2 cos omega 2t, two frequency components. Now in this, by comparing these two, you get omega 1 is 10 power 6 and omega 2 is 10. Whatever the capacitor of 10 microfarad here we have, it provides some reactance to this frequency. The reactance of the capacitor, what it provides, Xc1 is 1 by omega 1 C1. Similarly, Xc2 is 1 by omega 2 C2. Now just calculating Xc1. 1 by 10 power 6 into omega 1, 10 power 6 into C1 is 10 micro, 10 into 10 power minus 6. Xc2 is 1 by so next slide I will do that. Just before we calculated Xc1, Xc1 is 1 by omega 1 C1, which is 1 by 10 power 6 into 10 microfarad, 10 power minus 6, which is 1 by 10, 0.1 ohms. That is the Xc1 reactance. Xc2 is 1 by omega 2 C2, omega 2 C1. Okay, same capacitor, because we are using the same capacitor, but frequency is different. This is a input capacitance, sir. Input capacitance C1 I am taking this. Now 1 by omega 2, 10 into C is 10 into 10 power minus 6. It is 10 kilo ohms. It means at input side of your circuit, if you observe this circuit, this is our circuit. In this, here you are applying data, two frequency components you are applying, x cos 10 power 60, another one is y cos 10t. For this frequency, this capacitor is going to provide a reactance of it is 0.1 ohm. For this, it is providing 10 kilo ohms. Compared to this, it is 1 lakh times more. So that means this frequency component is for this frequency component, this capacitor is acting as a short circuit. 0.1 ohms is nothing, it is more or less a conductor, short circuit. And compared to this, for this frequency component, this capacitor acting as a open circuit. It means, first of all, this frequency component is not entering into the amplifier, so it is attenuated by the input capacitor. Okay, only this component is entering into the amplifier. Once it is entered, and it is going to be amplified, therefore output is gain minus 120 into input signal is, with respect to input signal is x cos 10 power 60. That's it. Minus 120 into x cos 10 power 60. So that is the answer. Minus 120 into x cos 10 power 60. This is the answer. Right option. Okay. So this is a very nice problem. So you may expect this type of model problems in your examinations. The very easy thing in this important thing in this problem is just they given the different frequency components. Okay, that is the easy thing they given in this. Clear? So we have so many problems. Next session we go on solve the remaining problems. Remaining problems we solve in next session. So here are the top educators from Unacademy. Tiwari sir, he is the IIT topper and he has 7 years of GATE and engineering service teaching experience. He is the author of the book GATE in 75 days. Ankit Goyal sir, he obtained All India rank 1, first rank twice in GATE electrical, and he was awarded President of India Gold Medal in IIT Indore. Jaspal Singh sir, he is ex-IAS officer, he got All India 4th rank, and he is the ex-senior faculty, senior MEDESE faculty. Sanchit Jain sir, he is the computer science faculty having experience more than 8 years. And here are few more top educators from Unacademy. So these are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. There are two subscriptions, Plus subscription and Iconic subscription. In Plus and Iconic, both the case, India's top educators are handling your subjects, best educators. Sorry, interactive live classes are there, structured courses and PDFs are available, and live tests and quizzes they will conduct. Now, then we show the difference between the Plus subscriber and Iconic subscriber in this aspect of live tests and quizzes. Once you attempted the test, that is forwarded to your personal coach. Personal coach do the analysis on that. Based on that analysis, they will prepare a proper, that is called personalized test analysis. Based on that, they will prepare a proper study planner to you, and after that, and with respect to that, they will provide respect to study material also to you. By following these two, every student can get success in their examinations. In Plus plan, there are different subscriptions: 1 month subscription, 3 month subscription, 6 months, 1 year, 1.5 year, and 2 years. For 1 year, it is 30,250 rupees. By using my code VRAV10 during subscription, you get it by 10% discount, 27,225 rupees only. And for Iconic plan, it is a 1 year subscription and 2 year subscription. For 1 year, it is 50,250 rupees. By using my code VRAV10 during subscription, you get it by 10% discount with 45,225 rupees only. Don't forget to use my code VRAV10 during subscription. And subscribers, if you like this video, subscribe this. Don't forget to subscribe and join our Telegram group for getting latest updates on our upcoming videos. Please give your valuable comments on YouTube. Thank you. Thanks for spending your valuable time with us. And once again, I'm welcoming you all to this beautiful online learning platform. And I'm thanking Unacademy to provide such a beautiful facility to me.